Hello, 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 and welcome again to Math with Mr. Taco. It is Dividing Fractions Part 2 day today. You're going to need something to write on and something to write with, and then let's go ahead and take a look at our I cans today. I can define inverse operation. I can write a multiplication equation that is the inverse of a given division equation, and I can write multiplication and division equations that match a given fractions model. So it's going to be a big modeling day. Again, as we take a look at dividing fractions, because it is a little bit of a nebulous concept and often one that doesn't get taught in school. For instance, when I was a fifth grader and I was learning dividing fractions, okay, all my fifth grade teachers did, because that's what was taught at the time, was they just taught me the shortcut on how to find the right answer, how to solve for n, the right answer. But did I have any idea what I was doing when I was doing it? No, not really. I just knew that you did the shortcut and that was that. You will learn the shortcut next week when we do start solving for n. Again, today's a day where we're not actually solving for n. We're conceptualizing what it means to divide by a fraction. All right? So let's start with dividing by whole numbers. Okay, 6 divided by 2 equals n. We're starting small here, okay? And I bet you can fill in what n is, but again, I'm not worried about it today. So we have our 6 things, and we're dividing them into 2 groups, the number of groups, right? And then our n here is the amount in one group. Okay, so in this case, we're going to take our 6 and we're going to put the 6 into 2 equal groups. I'm going to put an equal here. Equal groups. Okay, I'm going to take my 6, deal it out. 1, 2, 3, 4, 5, 6. And how much is in one group? 3. So our n equals 3. 6 divided by 2 equals 3. Now, when we change our divisor, this number here, to a fraction, the what it is, the number of equal groups, stays the same. So let's say now we're in 6 divided by 1/2 equals n. Okay? In this case, we're still taking our 6 things. We're putting them into equal groups, except the equal groups we're going to make is we're putting our 6 into 1/2. And this is still how much would 1 whole be. So this is where our fraction bars come in. And this is what you're going to see today on your exit ticket. So really, the whole thing, that's our n. Right? N equals the whole shaboom here. Okay? And we know that 6 is in 1/2 of a group, right? And since they're equal groups and it's half of an equal group, or half of a group and they're equal, what would be on this side then? What would be the other half? What would the other half equal? Right? It also equals 6, right? If 1/2 of something equals 6, the other half's also going to equal 6, because again, we're making equal. I was going to say even, and then I was going to say equal, and it came out evil. We're not making evil fractions, not today. That's a Halloween thing. We're making equal halves here. Otherwise, are they really halves? No, not really. Halves implies that it's 2 equal pieces here. And then, so what does our n equal then? If half is 6, 1/2 is 6, then our n would equal 12. 6 plus 6. Okay, 6 divided by 1/2 equals n, or equals 12. Okay, let's try another model, and then we're going to fill in our equation. Okay, let's look at this one. Again, the whole thing is n here. And let's put 5 there. Okay, so again, the amount in one group, the amount in the whole thing is going to be our n. And now let's think about, we've got our 5 is divided into what fraction of n? What fraction of the group? So we've got 5 divided by, and then what are these fractions? How many equal pieces do we have? 1, 2, 3, 4, 5. We've got 5. So this would be 1/5. So we end up with 5 divided by 1/5 equals n. It's looking similar to something else, isn't it? I'm checking the chat for any questions. Not yet. We're still answering very nicely. Thank you. Okay. Let's go back to our work yesterday with inverse operations, because we talked about up there dividing and multiplying, our best friends forever. They're inverse operations. They can undo each other. They're kind of the opposite thing, right? Division takes a quantity and puts it into equal groups. Multiplication takes a quantity and makes more equal groups, right? Kind of the opposites of each other. So, looking at our 5 divided by 1/5 equals n, what would be a multiplication equation that would be the inverse of this? So we take our 5, we divide it by 1/5, and we get n. We need to multiply that n by 1/5, and it gets us back to 5. So we're going to write that down here. We're going to write n times 1/5, or 1/5 of n, equals 5. Would you agree? So you're taking this whole thing, you're multiplying it by 1/5 or dividing it into 5, right? Because we talked about fractions being division in disguise, right? So multiplying by 1/5, essentially the same thing as dividing by 5. And we get 5 in each group. Can we figure out what n would equal then? If we know there's 5 in each group, what would n equal? We've got n times 1/5 equals 5. Yep. Exactly. We've also got, ooh, here's an interesting one. Someone says this as another multiplication equation. They said 5 times 5 equals n. Now, this isn't quite a true inverse. This isn't a true inverse equation here, because we're not it's not a true undo, right? We're not getting from 5 to n and then doing the inverse operation to get back to 5. This is more an equivalent equation, or an equivalent statement. It does the same thing, right? 5 times 5, right? 5 making 5 groups of 5 is the same thing as saying, well, if 5 divides by 1/5, or 5 is 1/5 of something, right? Same concept. So dividing by 1/5, multiplying by 5 are, in essence, the same operation. You're doing the same thing. Just like multiplying by 1/5 and dividing by 5 are essentially the same operation. Really interesting to point out there. I wonder if we'll use that going forward. Okay. Remember, for today, we do want to build on, I'm going to erase this for now. This is important, but I do want to erase it for now, because I do want us to make this link of inverse equations here and inverse operations. Okay, building on that knowledge. All right. Let's try a couple more on the digital whiteboard. So let me give you, it's blank currently, There we go. But let me give you I'm going to give you a model, and then it's going to be your job to write some equations. So let's go with, whoops, there's my cursor there. Okay, and then the whole thing is n. So if this is our fractions model, what might our equations look like to go with this, to match this model? Okay, we've got our n, our whole thing, divided into how many pieces? Right, divided into what fraction? And then we have how much is in each fraction, or how much is in each piece. So what might that look like? Let me check the chat. I see some people are typing. Let's see how far behind we are. I'm still getting a lot of, here we go. All right. So I'm seeing 12 times 1/4 equals n. Think about that one. 12 times 1/4. Are we taking our 12 and multiplying it by 1/4 or dividing that 12 by 4? What are we dividing by 4 in this case? Or what are we multiplying by 1/4 in this case? Okay, if we're going to use multiplication, there's two ways we have to do it, right? You could do n times 1/4 equals 12, right? Because I see a couple people in the chat putting this. Oops. Equals n. Okay. 12 times 1/4 equals n would look like this. You're taking 12 and you're multiplying it into 1/4, and you want to know how much 1/4 of 12 is. That would be 12 times 1/4. But our n is the whole thing in this case, which is why we would need n times 1/4 equals 12. Okay, I'm also seeing some 12 times 4 equals n. Sure, right? 12 plus 12 plus 12 plus 12. You could do that way. Okay, what other equations could we use here? We've got n times 1/4 equals 12. Yes. How about a division equation? Can anybody get a division equation in there? I'm seeing, 12 divided by 1/4. I'm seeing in there. 12 divided by 1/4 equals n. Yep, I'd agree with that. Right? You're taking your 12, and when you divide it by 1/4, you're saying, well, if 12 is 1/4 of a group, how much is the whole group? How much is one group? Just like if it was 12 divided by 4, it'd be 12 if you put it into 4 groups. How much would be in one group, right? 12, you're putting it into 1/4 of a group. How much is in one group? Okay, there's one more equation that we're looking for here. Often it's the trickiest one. We have n divided by 4 equals 12. Would be our, I'm going to put a comma there so we know that those are different equations. N divided by 4, right? You're taking your n, you're dividing it into 4 equal pieces, and there's 12 in each piece. Okay, so 4 different equations can come off of this particular model. Okay, 2 multiplication and 2 division. Let's see. Good. I'm just checking the chat for anything else. And if we want to know what n is, we can take a look at this model, right? So if we have 12 here, and we're divided into equal groups, how much are in each other group? Right, there's 12 in each other group. So what does n equal? And you can, theoretically, you could plug n into any of these equations, and they would match. Right? 12 times 4, the most straightforward, or 24 times 2, right? N equals 48 in this case. Okay, and all of these are true. 12 divided by 1/4 is 48. 12 times 4 is 48. 48 times 1/4 is 12. 48 divided by 4 is 12. Okay, all of those equations are true equations because they have the same value on both sides of the equal sign. All right, let's do one more. Good people pointing out in the chat, if you solve for n and it ends up being 3, then we're looking at a different model. Okay, let's try one more. I'm just going to leave you with it. Try this one on for size here. Try that on. Write some equations to match this model. If there's 17 in one of our sections, how many sections do we have? And then what is the whole thing equal? All right, while you're working on that, I will make my plug for Math Office Hour because it is incredibly important. And we're getting a lot of really good work done. Yesterday, we had a bunch of extra practice on how to make inverse equations with our dividing fractions, turning it into, n times that fraction to get it back to our original dividend. And we also kind of talked more theoretically about why the upcoming shortcut that some of you already are familiar with, why it works and why we're allowed to do that, right? With any shortcut in math, it's important to know why that's allowed, right? Why can, if I have 20 times 5, I can just do 2 times 5 and add a 0 at the end, and that gives me an accurate answer. Why is that allowed, right? Being able to say that is important. It makes your math learning your math knowledge more flexible, and it makes your math understanding more well-rounded so that you're able to kind of be more creative with math and be more creative in the ways that you can solve equations, okay? If you know the shortcut, but you don't know why the shortcut's a thing, then it's only useful in really one situation, and it's not useful in the other situations. But if you can understand that adding a 0 means that you're multiplying that value by 10, then you can use that to your advantage in a lot of different situations. All right, check in the chat one more time. Let's get some answers here. We've got 17 divided by 1/3. I would agree with that. 17. If that's 1/3, if we put our 17 in 1/3 of a group, how much does the whole group equal? That would be 1. Another one is, let's see, 1/3 times n equals 17, or n times 1/3 equals 17. Yep, that's the inverse of our of that first equation, right? 17, divide it by 1/3 to get n, and then multiply it by 1/3 to get back to 17. That's our undo equation. Okay, and then our other ones there, we've got n, tricky one using that commutative property, or that associative property, I should say. Somebody says 17 divided by n equals 1/3. That's one we didn't talk about, but yes, it is true. Wow, big brain there. Nice work. Any other ones? Let's see. We've got 17 divided by 1/3, 1/3 times n. We've got n divided by 3 equals 17. Yes, we've got our n there. Divide it into 3 equal pieces, and there's 17 in each piece. Yes, and the inverse of that would be 17 times 3 equals n, to get back there. And some of you are trying out putting the 1/3 or the 3 actually on the right side of the other side of the equal sign, putting the 17 and the n on the same side, which is next level, but can be done. All right, and some of you have said in the chat that, yes, n equals 51. We didn't need to know that for this exercise, but yes, we were able to figure it out. 17 times 3, or n divided by, what divided by 3 equals 17, right? Or 17 divided by 1/3 equals 51. And 17 51sts is equivalent to 1/3. So this one does check out. Pretty cool. All right, thank you for tuning in, everybody. Exit ticket is there on Google Classroom if you have questions or you just want to do some extra math. Come on into the office hour, and then we've got journalism at 11:30. So I will see you all soon. Thanks for tuning in. Take care. Good luck.